even though majority of the affiliated colleges have not participated in this, if we keep on postponing things like that and repeating things, it will be very difficult. Still, majority of you have not attended, and because it is a very important class, let me cover some of the important aspects of the previous class. Is it okay?
Okay.
Okay. Let us recollect some of the important aspects of what we have already learned. The per capita demand of water is 135 LPCD. For a population of 1 lakh, it comes to, you all can do it. This is a very, very important aspect. You should remember throughout. This is called tacit knowledge, or in something which you should remember throughout 24/7 basis. Right? 2 o'clock also somebody asks you, you should be in a position to tell it. For 1 lakh population, what is the water demand? 100,000 persons into 135 liters divided by person day. So person is take it off. So what you will get is 135 lakh liter per day, which comes to 13,500 meter cube per day. It comes to 13.5 ml. Why I am telling you this is, why you should remember is, in any examination, they will ask you for 50,000 population, or 2 lakhs population, or 1 lakh population, or 3 lakh population. So if you know for 1 lakh population, this forms something like a basis for you, a scale for you, and you will not be doing any mistake. That is the reason you should always remember for one standard parameter, that is for 1 lakh. So for 1 lakh population, for the population of Kakinada, it is 50,000 KL. Next sir. Let us recollect these things. These are all important in the aspect that this sort of information will be asked throughout your life, wherever you go. You must remember. It is called permanent knowledge. In interviews they will be asking, even in the examination also, even if without writing this information or without presenting this knowledge, your answer book should not be there. They may not ask you directly what is the yield of an open well or what is the yield of an infiltration gallery. But when it comes to selection of source, or when it comes to quantity of source, when it comes to quality of source, in all these things, whatever the question may be, this answer sits well. It fits well. So, such type of knowledge is a must that you must write in the answer paper. It's somewhere or other it appears in the answer paper. So I am not giving you the questions in the examination. I am giving you the answers which you have to write in the examination directly. You have to use all this material in the examination in an appropriate place. That is why you should remember all this throughout. There are open well has an yield of 100 to 200 meter cube per day. Tube well has an yield of 5,000 meter cube per day. In places like Kakinada or East and West Godavari districts, it is as high as 20,000 meter cube per day. And infiltration gallery, which is laid parallel to the river, it is 10 meter cube per day per meter length. As many as 20 well-known diseases can be prevented. They cannot be cured. They can be prevented. And just by drinking potable water or safe water or wholesome water. And the common diseases are this. Why I have written a few are in bold, or they are very common and popular diseases. Diarrhea is the #1 child killing disease, and every day 22,000 children of age less than 5 years they are dying. And the main reason for this is lack of potable water. if you can imagine, or if you know the main design parameters of such type of water supply systems, then for any other water supply system also, if I ask, you will be in a position to easily tell it. It will be very close to this. Next, please. Once again, there is a term called green engineering. Green means environment friendly, energy efficient, sustainable system. That is the meaning of the term green. So whatever we do, it should be energy efficient. That is, here it is solar energy is being used. Environment friendly, and you are doing everything with a concern for the society. So in a remote area, you are in a position to supply water, that is life, to the people, maybe in a small quantity, but without having any electricity. Just by using solar energy, we are able to supply water. That itself is the greatest contribution any engineer can make. Like this. This is a very popular disease, Minamata disease, due to dumping of mercury waste into the sea, because they thought that mercury has specific gravity of 13.6. Seawater has a specific gravity of 1.05. If mercury is inorganic, it is inert. It does not react with anything. It is inert, just like sand, river sand. It does not react. It is inert. So if we dump, nothing will happen. But one particular type of bacteria converted this inert mercury into methyl mercury, which is dissolved in water. As a result, the water is dissolved in the seawater, and the fish which started using this water, they can withstand very high levels of mercury also. So people who started eating these fish, they started dying. So most of the things, your simple science will not help you in solving the problem. Nature, there are so many complicated things which they happen. Generally, fish are considered as the index of pollution. If in a pond or a river or a stream, if fish are in good condition, it shows that the pond is good. It is not polluted. Fish are highly sensitive to dissolved oxygen and pH and several other parameters. Highly sensitive. If the dissolved oxygen is less than 5 mg per liter, they cannot survive. So they die. So if dissolved oxygen is less than 5 mg per liter, means that the water body is polluted. Because in normal case, dissolved oxygen will be in 7 to 8 mg per liter. Iodine deficiency causes these problems like goiter, swelling of glands, and cretinium, that is underdevelopment of mind and physics. Like this. Now let us study very briefly one water supply system. Throughout the world today, India has we have about 400 and nearly 500 cities are there in India. And throughout, not only cities, even small towns like nearby Pithapuram, all these Tuni, there are so many. In western East Godavari districts, there are 21 ULBs. ULB means urban local body. For example, Palakal is an urban local body. Narsapuram is an urban local body. Bhimavaram, it is an urban local body. Ongol, there are 2 or 3 urban local bodies there. Narsaravpeta is an urban local body. Palakonda is an urban local body. Like that, there are in East and West Godavari itself, there are 21 urban local bodies. So each urban local body has its own water supply system. In all the water supply systems, typically, if you know this, you know about every other thing. In fact, one of our faculty members of our colleges, Aditya Engineering College, Srimati Lakshmi, who is teaching this subject, she has done a very good work on Victoria Waterworks, and she tried to optimize the cost of operation of them. These are some findings of them, actually. So Victoria Waterworks Kakinada Municipal Corporation was established about 110 years before. It is provided with a 1 meter dia pipeline. It brings water 13 from Samalkot, which is 13 kilometers away. It is a cast iron pipe. So you all should know that the life of the cast iron pipe is 110 years. So whatever you do, it should be long standing. The design flow is 50,000 meter cube per day. the annual cost is towards operation and maintenance is rupees 8.75 crore per year. So if you divide 8.75 crore per year divided by 50,000 into 365 meter cube per year, you will get rupees 5.32 per meter cube. 1 meter cube is 1000 liters. So 1 liter it costs 0.5 paisa. So why the cost of treatment of water is so less when in the market 1 liter costs about 5 rupees. If it is Kinley or things like that, they cost almost 20 rupees. Why it is so? The reason is whenever the quantity of water treated is high, the cost of treatment per meter cube of the product it decreases. So because it is treating 50,000 meter cube per day of water every day, such a huge quantity, and the cost of the treatment is so less. Out of the 8.75 crore annual expenditure, about 1.2 crore per year are the chemicals, and alum alone costs about 1 crore. So the alum normal dosage is, let us say, 30 mg per liter alum dosage is sufficient. But the persons working there, you are the in charge of that. As an environmental engineer, you are the in charge of the system, water treatment system. The person working there is a third standard failed boy or girl, and they are not aware of all this, the science involved in this, engineering involved in this. So their simple knowledge tells them that if you dump more alum, the treatment will be better. So they will be dumping a lot of tons of alum, and if you can control this, you are saving lakhs of money every month. Every month you are saving lakhs of money. Let us see how you can do that. If you use lime and Nirmali seeds, which are naturally available seeds, in combination with this is a lab experiment which you all will be doing actually. For example, alum dose required is 80 mg per liter, you are adding alum dose. If you add 10 mg per liter of lime, then the alum dose may come down to 40 mg per liter from 80 mg per liter. So you have to see the net cost is cost of alum plus cost of lime, you have to find out. So unless you do this sort of economics, you cannot optimize the process. And as an engineer, you have to reduce the cost of treatment. Alum costs about rupees 15 per kg. For example, Yanam is there, Kakinada is there. All these places they get alum from mainly two places. One is West Bengal, another one is Gujarat. Including the cost of transportation, it comes to about roughly rupees 15 per kg. Let us understand some of the basic meanings of some of the words which we very commonly use. Whenever we say he is a green or she is a green, it means that they are environmentalists or they have a lot of love for nature. But when we say green, the actual meaning is, technical meaning of the term green is environment friendly, energy efficient, and sustainable. Sustainable means whatever activity you are doing for the next generations, these resources will not be depleted. Economics. Economics is the study of creation and distribution of wealth and resources. And what is the meaning of the term resource? Anything of value is called resource. And what is engineering? You all should very clearly understand this meaning. Engineering is, don't simply see the words of it, but try to understand and appreciate the inner deep meaning of it. Engineering is the application of mathematics and sciences for developing technology for the benefits of mankind. Engineering is socio-economic development using the available resources. Socio means social studies. Unfortunately, From 6th class onwards, most of you had aversion for social studies subject. You never read it. And without studying social studies, you cannot have responsibility towards the society. Society is nothing but the nucleus of society is your family. So without having a responsibility towards society, you will not be a responsible citizen. You will not be responsible towards your family also. You will not be responsible towards yourself also. So social studies, socio means society. You should always think about society. Second one is economic. How the different sorts of wealth or resources are distributed, how to create wealth, all this you have to do. According to Ramayana, Kirti Dhanam Mahadhanam. Fame is the greatest wealth. Currency also is wealth. Health also is wealth. Knowledge is the greatest wealth according to Mahabharata. Jnana Dhanam Mahadhanam. Yes, please. We have seen that very clearly. 1 mg per liter is equal to 1 milligram of fluoride per 10 to the power of 6 milligram of water. If it is chloride, 1 milligram chloride per 10 to the power of 6 milligram of water. So whenever we say ppm, 1 part of the substance per million parts of water, that's what we have to understand. So 1 mgf 10 to the power of 6 mg is equal to 1000 gram is equal to 1 kg. For water, 1 liter weighs 1 kg. So this comes to 1 mg per liter is equal to 1 ppm. 1% corresponds to, this is a very, very important question with reference to your gate examination, because some question related to this will be definitely asked, directly or indirectly. 1% corresponds to, anybody would say, in India, 60 lakh engineering students are studying engineering. 60 lakhs are studying engineering any given time, BTech and MTech in India. Out of these 60 lakh students, if you ask what is 1%, anybody would say it is 1 mg per liter or 100 mg per liter or something better. But you should be in a position to tell the correct answer. You can tell it only if you try yourself. 1 milligram calcium or chloride or fluoride is present in 100 milligram of water. Then we say it is 1%. Now multiply numerator and denominator with 10 to the power 10,000. Why we have to multiply with 10,000? That is common sense and presence of mind. Because we know that if you multiply 100 with 10,000, you will get 10 to the power of 6 milligram, which corresponds to 1 liter. So you know the answer. In which direction you have to convert. That is why you are multiplying with 10,000. Then you will get 10,000 milligram of calcium per 10 to the power of 6 milligram of water. That corresponds to liter. So this is 10,000 mg per liter. So 1% is equal to 10,000 mg per liter. This is a very, 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 very important point. You all should underline in your mind. There is one parameter which is most important to know whether water is suitable for drinking or not, whether water is suitable for irrigation or not, whether water is suitable for construction or not. For all these things, there is only one parameter. And to analyze that parameter, to find its value, it takes only 1 minute or 2 minutes. So whenever somebody gives you a water sample and asks whether it can be used for construction or not, for irrigation or not, for drinking or not, in 1 minute, less than 1 minute, you can tell it by conducting a test called electrical conductivity test. The unit of resistance is ohm, OHM, ohm. Reciprocal of resistance is conductance. So the unit of conductance is reverse of ohm, that is MHO, mho. If the value is measured in micromhos, that is 10 to the power of -6 mho. Now, TDS, the salts present or salinity in water, is proportional to the electrical conductivity. If the electrical, how to find electrical conductivity? Just take the water sample, dip the electrode of the electrical conductivity meter into that, you will get a digital value in this digital world. In a second, you will get the value in micromho. That's all. Multiply with 0.65. You will get the salinity or you will get the TDS, total dissolved solids. Total dissolved solids means the sum total of chloride, sulfate, calcium, magnesium, majorly. In addition to that, iron, mercury, manganese, lead, gold, silver, all these put together will be in just a few mg per liter. Whereas majority it is chloride only, chloride, sulfate. So for you to understand the actual values, Godavari river has a TDS of less than 300 mg per liter. Any water that you drink, Kinley, etc., you will have a TDS value of around this only. It is just like river water quality, it is less than 300 mg per liter. But the standards are 500 mg per liter. Is the desirable standard. If TDS is more than 2000 mg per liter, that water is not suitable for drinking. We have seen one fundamental principle, and that is any water which is not suitable, which is suitable for drinking, is automatically suitable for construction as well as irrigation purposes. But the reverse is not true. Water which is not fit for drinking may still be used for irrigation purposes and construction purposes. So you should understand that intricacy. Okay. So if TDS is more than 2000 mg per liter, you cannot use it for construction. And to know whether it can be used for construction or not, how much time it takes? 1 minute, maximum 2 minutes. Seawater has a TDS of 3.5%. That is 35,000 mg per liter. Only when the concentration is very high like this, for brine, etc., only we tell it in percentage. Otherwise, in ppm or mg per liter only we tell it. Next. Now, there are two questions you may ask. One of them was asked in GATE examination. The first question is a question asked in the GATE examination. How simple it is, just see. The standards, drinking water standards for nitrate in drinking water is 45 mg per liter. What are the standards for nitrate, nitrogen? That means you have to understand the question like nitrate is NO3. Nitrogen can be present in the form of nitrate expressed as equivalent to NO3. It is 45 mg per liter. Now the question is NO3 expressed as N. You have to give the value. What is your answer? Do it. Dare to commit mistake. You do not have calculator, you cannot do anything. MOOC programs are only for self-driven, sincere students. If you have a calculator with you, you are sincere, you are self-driven, you are sincerely studying. Nobody is watching you except your own conscience. నీ ఆత్మసాక్షి నీకు పోలీస్. అప్పుడే బాగుపడతావు. వాళ్ళకే క్లాస్. You have calculator? You have calculator? Okay. Anybody got the answer? Very easily can tell. Super. Exact value is 10.2. Super. How many of you have got 10.2? Good. Easily you can try. What is NO3? Oxygen is 16. 3 into 16, 48. Nitrogen is 14. Nitrogen is 14, no? 14. So 48 plus 14, 62. On a scale of 62, the standard is 45 mg per liter. On a scale of nitrate, nitrogen we are asking. As nitrogen. That means on a scale of 62 it is 45 mg per liter. On a scale of 14, nitrogen is 14. On a scale of 14, how much it is? 45 mg per liter into 14 divided by 62. What is 14 there? It is the molecular weight of M. What is 62? Molecular weight of NO3. So, what is the answer? 10.2 mg per liter. Fine, you have got 1 mark. You are in IIT. questions in examination, especially GATE and competitive exams, are very simple. You have to put pen on paper and try to do it. If you may not understand now, go home and just go through. It will click. You will understand very easily. That is why many textbooks, if you refer, the standards they do not give as 45 mg per liter. They simply say, when you ask for nitrogen, when you ask for nitrate, they simply say that it is 10.2 mg per liter. Both are correct. When a person says 10.2 mg per liter, you should understand that he is giving the value of nitrate as nitrogen. When he is giving the value of nitrate standards as 45 mg per liter, you have to understand that he is giving the value of nitrate as NO3. Now the second question you understand. The total hardness of a water sample as CaCO3 is 600 mg per liter. If 60% of it is by calcium and the remaining is by magnesium, then calcium as Ca is equal to dash mg per liter and magnesium as mg is equal to dash mg per liter. Once again, very simple. All of you just listen to me. Most of the parameters like alkalinity, hardness, even calcium, magnesium, they all are expressed as in terms of CaCO3 because Ca is 40, C is 12, O is 16, O3 is 48, total is 100. CaCO3 molecular weight is 100. So on a scale of 100, if you can tell a value, it is very easily that we can gauge things, measure things, estimate things. Now, the question here is very simple. The total hardness is caused by calcium and magnesium. It is 600 mg per liter as CaCO3. Now 60% of it is calcium hardness. So what is calcium hardness? 360 mg per liter as CaCO3 on a scale of 100. Now the question is, what is calcium as Ca? I am not interested in CaCO3. I want to know Ca as Ca only. Very simple. 360 mg per liter into 40 by 100 or simply 0.4. 40 is the molecular weight of Ca. Molecular weight of CaCO3 is 100. So 40 by 100. So 0.4. It comes to how much? Whatever it is. Similarly, magnesium. What is magnesium hardness? Remaining 360 mg per liter is calcium hardness. So remaining is magnesium hardness. So remaining is 240 mg per liter. 240 mg per liter is as CaCO3. As mg, what is molecular weight of mg? 24. So multiply with 24, you will get it. Next please. So these are the answers. The first question, the answer is 45 into 14 by 62, which comes to roughly 10.5 mg per liter. 10.2 is more correct. The second question is calcium as Ca is this much, magnesium as Mg is this much. You will be very much surprised that this second question also was a GATE question. Whatever you study in these classes, the advantage of these MOOC classes is that the best of all these competitive examinations you can crack. I can assure you that this subject you need not visit any college outside for coaching in competitive exams also. Everything will be covered in here itself. The only thing is you should listen with devotion. This is another GATE question asked in the GATE 2013. The question is 8 gram of SO2 occupies dash liters. This I have already covered and my voice is already recorded. So you can go through the previous class and go through this. Let me skip this. Next please. And these are all important conversions. You all should be, you are supposed to be very conversant with all these things. You should be very thorough with all these things. 1 square kilometer is equal to 100 hectares. 1 square kilometer is 256 acre. 1 acre is 4000 meters square. 1 hectare is 100 meter by 100 meter, which comes to 2.56 acre. Area of Kakinada is roughly 25 square kilometer. Area of Amaravati is roughly 250 square kilometer. Area of Chennai is 400 square kilometer. If somebody asks you what is the area of Bombay, you need not tell the exact value, but this forms as a scale. Easily you can tell that it is also around 400 square kilometer. You tell it as 500. It's fine. For Calcutta, it is 500 square kilometer. Fine, more than sufficient. But if you know some of the basic, the AP 150,000 square kilometer is the area. 1000 kilometer, you know, what is the length of the Golden Quadrilateral Road in Andhra Pradesh? 1000 kilometer. What is the length of coastline in Andhra Pradesh? 1000 kilometers. So what is the length of AP? 1000 kilometer. If you take average width as 150 kilometer, it comes to 150,000 square kilometer. There are 13 districts. Divided by 13, you will get around 11,000 or so for each district, an average. So for some districts it may be more, slightly. Some it may be slightly less. 1 meter cube is 1000 liter, that is 1 kiloliter. Kilo means 1000. 1 liter means it is space 10 centimeter by 10 centimeter by 10 centimeter depth. That is 1 liter. Mineral water bottle. It weighs 1 kg force. Water has a specific weight of 1000 kg force per meter cube. So specific gravity of water is 1. Concrete specific weight is 2500 kg force per meter cube. So specific gravity is 2.5. So if you throw concrete piece in water, it sinks to the bottom. If you throw it in the sea, it will go to the bottommost portion of the sea. If you go to the Pacific Ocean and throw concrete piece, there the depth of the ocean is 7 kilometer. So it will go down 7 kilometer and sink on the bottom. That is what you have to understand. For steel it is, for water it is done a mistake. For specific gravity of steel is 7.8. Its specific weight is 7800 kg force per meter cube. For air it is 1.22 kg force per meter cube. So what is the specific gravity of air? 0.0012. Here I will ask you another gate question. The gate question is, what is the molecular weight of air? You all may do it. Very, very quickly you do it. You need not get the answer. Don't worry about answer. Answer is not important. The beauty is not in the destination. It is in the journey. The process of learning only is correct. What is air? Air is 21% oxygen plus 79% nitrogen. So what is the molecular weight? 0.21 into O2, 32. 0.21 into 32 plus 0.79 into how much? Into N2, nitrogen, 28, which comes to how much? So the answer is, molecular weight of air is 0.21 into 32 plus 0.28 into 0.79 into 28, which comes to 28.84. Okkasari, how many of you have brought calculators? Please raise your hands. Sir, cover. See, unless all the participant colleges, if the student does not come to the class like this with a sense of devotion and determination and dedication, then take it for granted, you cannot do anything. Students coming with calculator and doing itself, they are giving wrong answers. But I am sure they will not give the wrong answer in the examination. If you do not have the habit of if you come without calculator, then you cannot do anything. It all is a mockery of Goddess Saraswati. Don't do that. Okay. So what is the molecular weight of air? 0.21 into 32 plus 0.79 into 28, which comes to roughly 29. So 29 is the molecular weight of air. Next please. Maybe if you get a chance to participate in Milo Everukotishwarudu, and if you get this question, you will get 50 lakh for this. My class may help you. Give 50% to me. To me means to the college, to the university, to the Mooc classes. This is called knowledge is the currency of future. Okay, next please. Now, if the flow is more than 10 meter cube per second, we call it as a river. Godavari has a flow of 75,000 meter cube per second. Amazon, if somebody asks you what is the flow of Amazon, it is 150,000 meter cube per second. You are quite correct. The exact value may be 200,000 meter cube per second. Is okay, 150 if you say. 1 TMC is 1000 million cubic foot. Once again, I am telling you, every political leader talks today about TMC. And as a political leader, as an illiterate person, they know that. And as an engineer, if you do not know the correct concept of what is TMC, it brings shame to yourself and to the university in which you are studying. So learn all these things very seriously. These are all the basic fundamentals things. If you don't understand, you can't understand anything in future. 1000 million cubic foot, which comes to 1000 into 10 to the power of 6 into 0.305. 1 foot is 0.305 meter. So it comes to 28 into 10 to the power of 6 meter cube. So 1 TMC of water can cater needs of 10,000 acre or 40 square kilometer. 2 days, recently last year, 2 days of Godavari river water was let out into the Bay of Bengal. So in 2 days, how much water will be wasted? 75,000 meter cube per second. 2 days means seconds. 2 into 24 into 3600 seconds, which comes to so many meter cube. What is the answer? So many meter cube, will get it very easily. And we already have studied 1 TMC. So many meter cube. Based on that meter cube, you find a TMC. 1 TMC is 28 into 10 to the power of 6 meter cube. So how many TMC? 460 TMC. 460. Very good. I don't know the correct answers, but I know that it is reasonably correct. If you tell it as 46.0, I will know that it is wrong. But if you tell it as 476, I cannot correct it because I do not have calculator. But I tell all answers based on common sense only. So I will not do a blunder. I will not do big mistakes. I may do small mistakes. So area of Prakasham district is there, for example. It is slightly less than 10,000 square kilometer. Now with this, 1 TMC caters to 40 square kilometer. You are wasting 460 TMC. So how many square kilometer it will be? 80,000 square kilometers. So how many such Prakasham districts can be satisfied? 8 districts. That means almost 80% of 70% of Andhra Pradesh you can supply water just if you can save this 2-day water which was otherwise wasted into the sea. So that is what as a civil engineer you have to think. Next please. This is a homework for you. Just we will discuss it in the next class. A 500 megawatt gas-based power plant has water demand of 30,000. Sorry, it is meter cube, not mm cube. It is meter cube per day. If detention period is 1 month, that means 1 month of water is to be stored in a pond. Design the pond. Design means you have to assume some depth. You assume some depth as 4 meter or 5 meter or 6 meter or 8 meter or 10 meter, and then you find the area of the pond. So many acres you find. Next page. Very simple. If you multiply with 30 days, you will get the volume. Today, if you observe the world, one of the major challenges of the world is water, supply of water. One solution today is, if you refer to internet, you will find Google. If you Google, the plan now is the ice in ice caps and glaciers is 100% pure. If these ice caps or icebergs, if they are thawed and brought to the areas which need water, fresh water, then the water problem can be solved. Let us see how feasible it is. This is what you are seeing is Siberia. The area of Siberia is 2.5 times that of India. Its area is equal to that of USA. That means USA and Siberia both have area 2.5 times that of India. So majority of it is covered with ice. In the temperatures you will find always as minus 40, minus 50 degrees centigrade also. Next. But it is, ice is full of pure water. Time. Okay, hurry up. For example, the beauty of this concept is it is in the middle of the ice, middle of the sea, you are finding the iceberg. Sea water contains, you name any pollutant in the periodic table, you will find it in the sea water. Because water, when it falls on hills, mountains, rivers, streams, lakes, all that water ultimately has to reach the sea. So it absorbs all the minerals on the ground and in the rivers, and the medicinal values of the plants, and all that it will ultimately reach the sea. So sea contains all minerals. But when in the middle of the sea, when water becomes ice, only pure H2O becomes ice. So this iceberg, whatever ice you are whatever water you are finding in that is 100% pure H2O. It does not contain a single salt. That is why, according to psychology, human beings are all compared with icebergs. Even though you are in the middle of people who are not interested in studies, who do not have any sort of value, who do not have any respect for studies or knowledge, you are in the middle of such type of persons. But if you, as an individual, if you want to shine, you can always shine. You can show your interest. If you show that interest, because of that quality only, you will be lifted upwards. So, because it leaves all the bad qualities in that, he is not attached to those bad qualities. That is why it will be lifted and is projected to the world. This is a very, very beautiful concept in psychology. But leaving that, let us see what is the volume of water present in this. The iceberg that you are seeing is of size 300 kilometers. Let us. The volume of this iceberg is 300 kilometers. It is length. Length is 300 kilometers. That means Kakinada to Guntur. Width is 100 kilometers. That means Kakinada to which place? Taduku. And depth is, let us say, take it as 50 meters. 50. So what is the volume of pure water present in it? All of you should know that the water present in an iceberg is just like distilled water, pure distilled water. So it comes to so many meter cube, and we know that 1 TMC is equal to 28 into 10 to the power of 6 meter cube. If you are not happy with these conversions, if you are not strong with these conversions, every minute you will be facing hell. Studying will not give you happiness. So 1 TMC is equal to 28 into 10 to the power of 6 meter cube. 1 TMC caters to the needs of 10,000 acres. So how much of area this one single iceberg can satisfy? You can calculate. Is it not very huge? So what we have to do? We have to drag this, and we all know that any floating body has a net weight of 0. It will have some downward weight, but buoyancy will be there. Any floating water always exerts an upward force on the floating body, which is equal to the downward force. So the net weight is always 0. That is why you can suppose an elephant is swimming. Elephants are outstanding swimmers. While swimming, what is its weight? 0. That is why you can lift it. If you want to lift an elephant, what you have to do? You throw it into water and then lift it. Maybe it is on a lighter side, but there is it is fact that any floating body, all mammals are swimmers. All mammals have specific gravity less than 1, so they always float. So any mammal like tiger or hippopotamus or rhinoceros or elephant or human being, when he is floating, you can very easily lift. There is no net force. You can very easily observe it if you put a bucket in water. As long as it is immersed in water, you will not find any weight. The moment you bring it out, you will find suddenly there is a lot of weight. So using, it is very easy to bring them. Now using the same concept, this is an advanced method of treatment of water. This is part of your syllabus. Advanced treatment methods are mainly freezing, distillation or solar stills, reverse osmosis, ion exchange, electrodialysis. These are the standard methods. Out of these two methods we will be studying in the next 5 minutes, and that is freezing. The simple example of this is, you bring seawater which contains 35,000 mg per liter dissolved solids. You keep it in the freezer compartment of the refrigerator. It becomes ice. When it becomes ice, it leaves the salts behind. Salts will not enter the solid phase of ice. So once it becomes ice, you take it out and then again keep it in a beaker. It is melted, or keep it in a utensil. It is melted. Once it is melted, you will get pure water. As simple as that. For example, in some areas, nighttime temperature will be less than 0 degrees centigrade. Daytime temperatures will be very high, more than 5 degrees centigrade. So in such cases, what you can do? If it is a coastal area, or if the lake is a salt lake, then what you can do? Nighttime it becomes ice. All lakes, they become ice nighttime. So you bring out that ice onto the shore. Next day morning when it melts, it becomes pure water. That is how you can obtain pure water very easily. But the condition of this is that if the temperature is less than -8 degrees centigrade, Na2SO4 crystals are formed. If the temperature is less than -23 degrees centigrade, sodium chloride crystals are formed. So what is the ideal range of temperature to get pure water from seawater? You have to maintain a temperature of in the range of -80 degrees centigrade to 0 degrees centigrade only. If the temperature is much less, then what happens? Once these crystals are formed, they cannot be distinguished between ice crystals and these crystals. They cannot be distinguished. So you do not know how to separate them. Separating will be another problem. So if the temperature, if you maintain in this range, you will not have any problem. It is a very, very important aspect. Without this, there will not be any examination. That means whatever you are writing, you are seeing in this slide, it should appear, it can appear as it is in the examination, as an answer. Once again, I am telling you, I am not giving you the questions. You need not have to prepare the answers for it. I am giving you directly the answers. There will be some, without asking about the advanced methods of water treatment, is it possible? Already your syllabus is very, very less. Next please. Now I am giving a beautiful assignment. Engineering is completely, the thrill of engineering is in labs only, conducting labs and experiments. So conduct this experiment in your lab is very, very easy, and that is get seawater. If you cannot get seawater, add 5 grams of table salt to some 100 ml of water and mix it. Find the TDS in 1 minute. How? Seawater, you dip the electrode in the seawater, you will get the TDS directly, conductivity you will get multiplied with 0.6, so you will get around 35,000 mg per liter. Otherwise, if you take table salt and mix, you will get some value, more or less same. Now that salt water or seawater, you keep it in the freezer. It becomes ice. You bring it out, take it out, keep it in a beaker. It gets melted. Find its TDS. You yourself will know what is the efficiency of the system. And another thing is, what you can do is, if you take out the ice, what happens is, the salts will not join that. But when they adhere to that, they attach themselves to the ice. So when the ice is melted, these salt particles also will join that. That is why when you take out ice, you see that it is washed under a tap, or using some water you wash it off, so that the salt particles attached to that externally, they are washed off. And then you see that it is melted. Then you will find that the efficiency is very, very high. So these are all the small techniques which you can adopt to obtain pure water and drinking water from seawater. Next please. Assignment 2, and that is take seawater or add about 35 grams. 35 can be 45, 50, 60, no problem. 2,000 ml of water, about 1 liter of water. That is in a mineral water bottle, ordinary bottle. You need not take distilled water also. Take this much of salt and dump it. That's all. But measure it before dumping it. We know that TDS is equal to 0.65 into EC expressed in microbar per centimeter. So now you boil that water. If you boil, what happens? Only pure H2O gets evaporated, leaving behind the salts. So once this is done, you find the TDS in the remaining water. It increases. Now you do another thing. When you are boiling, keep a plastic sheet above it. Any polythene cover. For example, you have a polythene cover given along with the milk packets and whatever it is, any polythene cover. You take it and keep it on the top as a roof. Now whatever water is evaporated, it will drip, it will be condensed. The moment you keep it, it will be condensed and that will drip. You collect that water sample, a few ml, and find its TDS. You will be surprised to know that the TDS in that water is almost zero. Very, very less. It is again distilled water. That is why rainwater is nothing but distilled water. Because seawater is getting evaporated. It is getting condensed and then it is raining. So seawater is nothing but distilled water. So you will get pure water as rainwater. So same purpose. Any process which you do which is close to nature is bound to be a success. And environment friendly nature means you adopt technologies which are close to nature. You imitate nature in your actions. So this is your second example. Next please. The second method of treatment of water, converting seawater into drinking water or seawater into pure DM water, demineralized water or distilled water, is by this method, and this is called distillation. This particular method is called solar distillation or solar still simply. In this, you take it is exactly to the one which I have given already assignment to you. This is brine or seawater. You see that it is evaporated, and on the top you keep some plastic cover as a roof. Whatever water is getting evaporated, it will attach to the inner side of that roof and it will be condensed, and that will gradually drip down. It will flow down. You collect that fresh water. You can do it very simply. This method is called solar distillation or solar still. But any technology which is very close to nature is slow and steady. It does not consume any additional expenditure. It does not harm the environment. For example, this sort of treatment, does it require any power? No power costs. Does it create any load on the environment? No. Is it consuming any resource? No. It is 100% environment friendly. But the only disadvantage with this process is that the rate of obtaining pure water is low. The rate is slow. Water is low in quantity. So it gives only 3 liters in a whole day per meter square. So if you increase, there are even today some stills where you will provide 100 meter square area they cover with plastic covers. On the sea, they keep some floating objects, and on those floating objects they keep some sticks there, and on the sticks there will be polythene covers. And in a natural process, seawater is getting evaporated and it drips down, at the end they collect it in the form of a small particular arrangement canals, and that water you can get it. If it is a 100 meter square area, you will get 100 into 3, that is nearly 300 liters. And 300 liters is not a small thing. Distilled water today costs in the market almost like 30 rupees around, easily. So 1 liter costs 30 rupees and 300 liters, 300 into 30. You are getting in a single day. All this by using polythene, waste polythene sheets. Next please. Now, this is yet another very important topic. Every point that you are seeing can be reproduced as it is in the examination. And not only your examination, throughout your life, as an environmental engineer, you will be using this. You have to remember certain things, not everything. IS 10500 1991 gives the standards for drinking water. It is revised in 2012. Now, whenever it is revised, generally the new changes are kept in the internet, and all the students, all the public, they are told that we are keeping the standards here. If you have any objections or if you have any suggestions, you may give us. And the government is always ready to involve or include your suggestions into that. It is unfortunate that even BCom, BSc students, they send suggestions. Whereas, even though you are all hardcore civil engineering students, you are not even bothered about them. For example, Amaravati city has come. The master plan is there in the internet. The government is selling all our design aspects of Amaravati city. We have kept it in the internet. Please go through that and give us suggestions. We will implement them. How many of you have seen? Please raise your hand sincerely. Any college, all colleges. You ask yourself, this police, it is our responsibility. You may or may not be one or two suggestions you can always give. You can suggest simply that there must be some garden exclusively meant for medicinal plants. Let it be there. Can't you give that small suggestion? Or you can always say that in several developed countries, municipal sewage is treated by industries. Almost all industries are using municipal sewage, converting the municipal sewage to processed water. In our case, let us provide this for at least one or two industries of Amaravati. Today, the number one concept in the entire world today is, for green technologies, it is ZLD. ZLD stands for, please write, zero liquid discharge by an industry. That means when an industry uses water, the amount of liquid going out of the industry boundary is zero. Please note it. The amount of liquid leaving the industry is zero. So in this zero liquid discharge, what they do ultimately is exactly similar to the solar stills. When they completely treat the water, you will get a lot of sludge. That sludge, it will be evaporated. When it is evaporated, what happens? Just like after playing a game, if why a white color patch is found on the dress? Because it has we have a lot of sweat. That sweat is nothing but brine, salt solution, concentrated salt solution. The pure H2O, it gets evaporated, leaving behind the salts. So we will get a white patch on the dress. And the same way, this sludge from the industry, if it is boiled or if it is evaporated, then pure H2O gets evaporated completely, leaving behind the solids. That solid can be disposed of. That solid is disposed of in a different manner. So this is called zero liquid discharge, and today entire world, civil engineers are looking towards this concept. It is called green technology. Okay. Now let us get back to this. The standards here these are all drinking water standards. And we all know the thumb rule that any water which is suitable for drinking is automatically suitable for construction as well as irrigation purposes. That is for gardening, etc. The color, the apparatus used is Hazen's apparatus. It is 5 is the desirable standard, 15 is the permissible standard in the absence of alternate sources. You should understand IS code gives both these values. Desirable means desirable. Permissible means it is still desirable. It is still allowable. But to the extent possible, this is, you try to follow this. But if there is no water source at all, then you can go for it. Not a problem. For example, children of age less than 5 years, especially infants of age less than 1 year, if they are there in your house, they are very sensitive to water. And how much quantity water they drink? They do not drink with the mineral water bottles, they drink with spoons. And a few ml they drink, children. So when they are there, don't provide them this water. Provide them with bottled waters, that is mineral water, good quality water. That is what you have to understand from this. For odor, it is agreeable. For taste, taste should be agreeable. pH, it should be in the range 6.5 to 8.5. There is no relaxation means, again you can write 6.5 to 8.5 only. pH and turbidity, 1 to 5. Some 20 years before, turbidity was measured as platinum cobalt scale. It was a qualitative expression. By looking at, you have to write the values. Later it was Jackson turbidity meter. Most of your seniors studied about Jackson turbidity meter and platinum cobalt scales only of measuring turbidity. But today, technology is fast developing. Those things are not even taught to you. Today, the latest equipment is nephlometer. Nephlometer is an instrument that measures turbidity. What is turbidity? Turbidity is the resistance to passage of light. It gives the murkiness of water. Murky means dirty. It is an English word. So how does a nephlometer work? Here a light source will be there. Here water sample is taken. Here luxmeter will be there. What is luxmeter? It measures intensity of light. In cricket matches also, whether sufficient light is there or not is measured by the umpires by an instrument. That instrument is called luxmeter. It measures intensity of light. So here the light source comes. If the water is highly turbid, then the luxmeter gives a very small value. Intensity of light received by this will be very less. If the water is distilled water, entire light will be received by this. So depending on this, the instrument is calibrated. That is the basic principle of nephloturbidity meter, which you all should know it. And that value is 1. Maximum permissible value is 5. Here I should tell you that in the 1991 standard, this value was 5. That value was 10. But drastically they are now decreased. They have now decreased. Turbidity, to small extent, it does not harm us, but the consumer acceptance decreases. What is meant by consumer acceptance? We are all consumers. We consume, isn't it? We consume water. So we should drink sufficient amount of water. The moment water is turbid, what happens? It is a psychological factor that we do not consume sufficient water. So it leads to problems. That is the main problem. Color and turbidity, color, odor, taste and turbidity. All these four, if it is less, they are not that harmful to us. But the consumer acceptance decreases. It leads to psychological problems. Psychological problems in the sense that a feeling that I am drinking water which is not good. Then TDS or salinity. This desirable standard is 500. Maximum permissible standard is 2000 mg per liter. These are very, very important standards. pH, turbidity, TDS. Without writing the last 3 lines, if your answer paper is there, it means that you are a... Okay, let us go. It is stupidity. Because I am giving you the answer. We all know that pH is minus log H plus, minus logarithm of hydrogen ion concentration. its value, its theoretical range is 0 to 14. Fresh distilled water has a pH of exactly 7, and pH of 1 represents pH of normal rain has a pH of 5.6, because rain, when it falls, it absorbs CO2 and forms mild carbonic acid H2CO3. H2O plus CO2 is equal to H2CO3. So normal rain itself has a pH of 5.6 or more than that. But if the rain has a pH of less than 5.6, it means it must be due to sulfur dioxide. It is called acid rain. So normal rain has a pH of 5.6 or more than that. Then tomatoes have a pH of 4.2. Wine has a pH of 4. Apple juice has a pH of 3. Soft drinks, cool drinks have a pH of 3. Vinegar has a pH of 2.5. Battery acid has a pH of stomach acids. All the chemicals inside our stomach, they are all acids only. That is why we should never drink distilled water. We should not drink rainwater. We should not drink DM water. Why? Unless water has that alkalinity in that, chemicals in the, some substances in that, salts in that, it cannot fight the change in the acidity. So the acidity in the stomach can be neutralized only by the alkalinity present in the water. So water that we drink should have alkalinity. Distilled water has no alkalinity. Rainwater has no alkalinity. That is why we are not supposed to drink them. Once in a while, like the movie, like as in movies like Varsham, Trisha drinks it. It is okay. Lemon juice, the pH of 2. It is highly acidic. And in examinations, we all suffer from acidosis. It is natural, but natural that mind and body are interrelated. They are very closely related. If you are in tension, more acids are produced. If you are in fear, more acids are produced. So in examination, naturally, you will be in a bit of tension. Acids are produced. Your friend, he will suggest cool drink, you have cool drink. What happens if you drink cool drink? Cool drink has a pH of 3 or less than that. So the situation will be worsened. It is further aggravated. That is why cool drinks should not be used for drinking, especially during examinations or whenever you have acidosis problem. The only solution to such type of things is drink water, which has alkalinity. That is normal water. Next please. These are all the standards, and majority of them you have to remember. There is no other way. But how to remember in a logical way with reasoning, I will tell you now. For example, see the last 4 lines. When I am talking, listen to me. When I am talking, you are busy writing those, noting down, you will not get anything. You will get it. This is your property. Anytime you want, you can go through that. But this sort of analysis or explanation, you will not get it. In future also, you need not have to remember all this as it is. But you should know why they are kept like that. Now let us see. Chloride as Cl, the standard is 250 mg per liter. Chloramine, the standard is 4.0 mg per liter. Chloramine means combined with ammonia. Chlorine and ammonia are together. Then chlorine is not that dangerous. As an individual, it is called radical. R-A-D-A-C-A-L. Radical means in its very free and violent form. If it is available freely as in a radical form, it is very, very dangerous. Maximum number of deaths in the world are due to chlorine. Please note that. All swimming pools use, all water treatment plants use chlorine. And chlorine gas is used. And because it is highly dangerous, very poisonous. Then free residual chlorine, it is 0.2. What does it mean from these 3 parameters? In all the 3, it is only the chlorine which is harmful. But the intensity with which it depends on its form. If it is available in a radical form, it is very dangerous. That is why at 0.2 itself it is very dangerous. But If a good ammonia is present in its is there when it is on its side, then it is not that violent. The concentration is 4. That means how many times? 5 into 4, 20 times less harmful. And if it is available in the form of chloride, it is 250. You all know that wife and husband should always be like sodium and chloride. Wife like chloride, husband like sodium. Na plus is positively charged and it is highly poisonous, very dangerous. Cl minus is highly poisonous as an individual. But when both of them combine, NaCl is formed, which gives to taste to life. So, whenever as an individual you may be very violent, but when you are forming a relationship with somebody, maybe your father or mother or friend or whatever it is, you should shed, you should throw out your poor qualities and give taste to your relationship. You have now understood, I hope. For example, in an examination, when we ask this, you should know, if you write instead of 250, if you write it as 200 or 500 also, you will get marks. It is correct. But instead of 250 for chloride, if you write it as 0.2 or 0.5 ppm, then you are 100% wrong. Similarly, for free residual chlorine, if you write it as 1 ppm also, it is okay. If you write it as 2 ppm also, it is okay. But if you write it as 250 ppm, then you are utterly wrong. So that is what you have to distinguish between these values. That is how you have to remember them. With some logic and reasoning, not blindly. Similarly, calcium and magnesium. Now you will know that for hardness, what is the value? 200 mg per liter. Alkalinity and hardness more or less both have the same quality. Alkalinity also is caused by calcium and magnesium. Carbonates and bicarbonates of calcium and magnesium. Hardness is caused by bicarbonates and bicarbonates of calcium and magnesium. So as a result, both standards are same. Earlier the standards were different. In 1991, previously the standard for hardness was 300 mg per liter. For alkalinity it was 200 only. But now they have changed it. They made it simplified. They simplified it. Now out of this 200, let us say how much should be the value of calcium? That is expressed as CaCO3. Now here it is expressed as calcium as Ca is 75. So what does it mean? Naturally, if you what is calcium as Ca if it is 75? What is calcium as CaCO3? What is the value? Calcium as Ca is 75. What is calcium as CaCO3? 75 by 0.4, which comes to how much? 187. Obviously, it should not be more than 200. Because for the standard for hardness itself is 200 mg per liter CaCO3. How can calcium as Ca be more than this? So you have to remember that when total hardness as CaCO3 is 200 mg per liter, calcium hardness as CaCO3 can be at the most 200. If calcium hardness standard is 200 mg per liter as CaCO3, what is its value as Ca? 200 into 0.2, 80. That is why it is kept as 75. Suppose the entire hardness is made by magnesium only. Assume like that. The entire hardness is made by magnesium only. As CaCO3 it is 200. Magnesium as CaCO3 is 200. Magnesium as Mg becomes 200 into 0.24. Which comes to how much? 48. That means it cannot be more than 48. So they kept it as 30. Am I clear? So if you write it as 50, then you are wrong. If you write it as 20 or 40 or 30 or 37 also, you are correct. That is how you have to understand that it is not that calcium directly you are remembering. It is linked to total hardness, alkalinity, calcium and magnesium. All these are interrelated. You should understand that these are all one family. Then ammonia as nitrogen is 0.5. Ammonia, nitrogen in the form of NH3 is highly pungent. Even smallest amount also it gives a very bad smell. It's highly toxic. It is carcinogenic also. Whereas as nitrate, its value is 45 mg per liter. We have already studied for nitrate. Nitrogen, it is 45 into 14 by 62, which comes to 10.3. That is why some books give it as 10.3. But if you see IS code, in that they have not given all this. They have given nitrate as NO3 45. Next please. But you should know that nitrate as N is 10.2. Next please. Then you have to remember that aluminum, which we get in foils, sweets are covered with aluminum foil. Copper vessels we use, and silver, fluoride, zinc, all these the values are very less. You have to remember. Zinc leads to what is called opalescence. Opalescence means a whitish color, it gets it. Whitish color. So for it is 5 mg per liter. Whereas for all other things, it is only 1, less than 1. You should remember that they all belong to one particular category. Iron and manganese are like very close friends. They always live together. If iron is present, it gives red color to water. That is why paper industry, water should not contain any iron. It's a fundamental rule. If it contains iron, what happens? If a paper industry contains water, if the water used in paper industry contains iron, what happens? The paper will get reddish color. Textile industry, it should not contain even trace of iron in water. Why? What happens? Textile industry, if it contains, staining will be there. Staining. Small spots will be formed in the textile. It will lose its textile strength. Iron should not be present in water used in paper mill or textile mill. It is a very simple fundamental aspect. If iron is present in drinking water, it gives reddish color to water. If manganese is present in water, it gives blackish color to water. Next please. Just a minute. We know that for sulfate also is a very important point, especially for civil engineers. It is very important. Just like chloride. Chloride, what is the standards? What are the standards for chloride? Tell some value. 250. Don't say 0.2. Chloride. Along with sodium it is present. When it is present along with sodium, chloride is present as sodium only. NaCl combination only. So it is not dangerous. 250 mg per liter. Chlorine freely it is 0.2 mg per liter. So chloride it is 250. Sulfate it is 200. Both are more or less the same. If you write for this also 250, it is okay. If you write for chloride 200, it is okay. What are the main effects of chloride and sulfate? Please write. Strength and solidity of concrete will be badly affected. Strength and solidity of concrete. 10 minutes. So what happens if chloride is present in soil, in water? If you use that water for construction, then in the reinforcement will be eaten away by chloride. What happens in a salty atmosphere like Kakinada, where seawater is there, seawater breeze is there? What happens if reinforcement is exposed to the atmosphere? It is eaten away. Once it is exposed to the atmosphere and eaten away, the strength of the concrete is gone. The structure will collapse. So same is the case if water contains excess chloride or sulfate, then the strength of the concrete will be very less. The solidity of concrete will be very much affected. So chloride and sulfate, they are mainly connected with this aspect of civil engineering. And when it comes to drinking water, if chloride is there in excess, then it leads to cardiovascular diseases. Please write. Cardiovascular diseases means heart problems. We all heard it here very frequently. We say uppu muppu. Uppunte muppunnatte. Uppu means salt. Muppu means danger. If you are consuming excess salt, you are in danger. Now see one more observation. Sulfide. What is the value? 0.05 only. But if sulfur is present in the form of as SO4, its form is very important. You also observe your own lifestyle. As an individual, you are a saint, maybe. But in the presence of another person, you tend to be more mischievous sometimes. In the presence of some of the friends, you become more saintly, very calm and quiet. What is the reason? Your form, the person with which you are associated is very important. Same is the case with this. Whether it is in its free form or it is in combination with sodium or potassium, the harm it causes depends on that only. Just like your own personal life. Next please. Now this is another big table you have to remember. You need not remember. It is only common sense. In one look, you can observe this. For example, in this, gold is not there, Rm is not there, silver is not there. But in the examination, suppose they ask you, what is that you will write? They are all highly toxic substances. What is meant by toxic substances? At very low concentration, they are dangerous to life. So for all this, if you observe, the values range always 0.01 or even less than that. At such a low concentration also, they can kill you. If the concentration exceeds, for example, cyanide is there, it is 0.01 or something like that for cyanide. Maybe here it is not there. Yeah, 0.05 it is there. And if it becomes if it becomes 1 ppm, and if you drink that water, you are gone. Instant death. So that is the reason they are highly toxic. Okay, next please. Then this is microbiological testing is done. This is for what is called, please write one word, MPM. Earlier the standard was given as MPM. Now they have changed it. MPM stands for most probable number of coliform bacteria in 100 ml of water. MPN, all capital letters you must write. If you write small letters, it is a mistake. You will not get marks also. These are the mistakes, most of you do it. Most probable number, M capital letter you must write, P capital letter you must write, probable, number, N must be capital letter. Because MPN you have written in capital letters. If you write in small letters, it is a mistake. You will not get marks. Small things make very big differences. These small mistakes also, they count in a very big way in life. Most probable number of coliform bacteria in 100 ml of sample. That was earlier. But you should know how to write that also. So these are all the standards that shall not be detectable in any 100 ml of sample. When it comes to coliform bacteria in distribution water, shall not be detectable in 100 ml of sample. Very easily you can remember. For all these things, one stroke. Guinea worms are now almost extinct. You will find them in stepped wells. In many villages, the wells, huge wells will be there, and there will be steps to get into them. So when your feet come in contact with water, certain types of worms they develop, and that problem is solved because to a great extent stepped wells are banned. But even now there are some wells. So the disease is called Guinea worm disease. So if this worm is there inside the body, you will find almost 2 to 3 meter length worm will be there. Worm will be of very small size only, 1 mm only, but they live in colonies. They live in, it appears like a thread. You must have seen in many medical videos. If you go to net also, you will find it. If Guinea worm problem, if it is there, for if you drink this type of water, then once when its size grows, it comes out from the body in the form of a thread. Just like a thread, it comes out. And if you leave it, the entire worm will come out. You will find the length to be almost 3 meters sometimes. 3 meter long worm comes out from your body. So all this is done because of this Guinea worms, because of stepped wells. Next please. We have come to the conclusion part, and our next class I will tell about the treatment of water, and this also is very simple, and this subject of water supply engineering as well as the next subject of wastewater engineering, and in all these subjects one reactor that always comes and very important is called clarifier. And how to design a clarifier? This is the design parameter. It is 40 meter cube per day it treats per meter square of the surface area. That means it is a circular tank of depth 3 meters or 4 meters or 5 meters depending on the diameter. Now how to find the surface area? Pi d square by 4, how to find it? If you know the flow, that flow divided by so many meter per day. Meter cube per day per meter square means meter per day only. So if you divide meter cube per day by meter per day, you will get meter square. As simple as that. So you have to understand and appreciate the gate examination, that just by observing the units, you can solve the problems. You need not even understand the concept. For example, now water treatment chapter I have not started. You do not know anything about it. But suppose I give you what is the diameter of a clarifier to treat for Kakinada. Can you design or not? Next please. See this problem. Design a clarifier for a town of population 1 lakh with a minimum detention period of 2 hours. You need not know anything. Just the presence of mind. Just the presence of mind. Assume that you are a student studying without arrogance, studying in 8th class or 9th class. That's all. You will solve this problem. Don't apply your engineering here. Be a common man. Think like an ordinary, simple human being. You can solve this problem. Let us solve this. Q is equal to 100,000 persons into 135 liter per person per day. You will get 13,500 meter cube per day. Design surface loading is 40 meter cube per day per meter square. This is, you have to remember, in our examination system. Whereas in gate examination system, they need not remember anything. They give this value. The only thing is you should convert it to meter per day. Or sometimes they will give directly as meter per day. This value also they give. So you divide it. You will get surface area. Pi d square by 4 is equal to 13,500 by 40, which comes to 337.5 meter square. So diameter is equal to how much roughly? You will get it very easily. Around how much you get? First use common sense. Don't use calculator. Before using calculator, use common sense first. This is roughly 400 meter square. That means around 20 meter will be diameter. 20 meter. But it is less than that. So you will get around 18 meter. Now detention time is 2 hours. 2 hours means 2 by 24 day. So what is the volume of clarifier? Just observe the units. This is that is meter cube per day. This is per day. So multiply both. Day get cancelled. You will get meter cube of the clarifier. 13,500 meter cube per day. So answer is 1125 meter cube. Assume depth as, so find the depth. What is the depth? You know the volume. You have already calculated the surface area as 337.5 meter square. So what is the depth of it? 1125 meter cube divided by 337.5 meter square. 3.5 meters. This is a 8-mark question. A very big question. And there is no complication in this. And without this, the subject is not there. Throughout tomorrow, next class when we start water treatment, every day we will be studying clarifier. Wastewater engineering, another subject comes next semester. It is completely about clarifier. Every day clarifier topic comes. And if you don't remember these things, throughout life you have to struggle. Next please. We are in the next class, we will study this. But before that, alum is used. We all have studied that every year we use about 1 crore worth alum. So if you can reduce this, you are saving a lot of money for your society, for your town. So in place of, that is on the right side you are seeing alum. More or less it appears like this. And on the left side you are seeing a plant. It is called Nirmali seeds. It is available in Andhra Pradesh and several other states of the country. these seeds, if they are made into the form of a powder, and along with alum, if you use it, the dose of alum can be reduced from 80 mg per liter to 30 mg per liter also. And these are all naturally available. So that is how you have to think. And this test is a very important test you will be conducting in your lab also. Next please. Alum is Al2SO4 thrice. So this is the last slide you are seeing today. Just find it very quickly. What is the monthly requirement of alum at 80 ppm dose to treat water for Kakinada? If I am doing for Kakinada, it is just like the same answer you will get it for Rajahmundry. Same answer you will get it for Ongole. Same answer you will get it for many towns like this, more or less. Simply multiply them. Kakinada is 50 mld. 50 into 10 to the power of 6 liter per day. Multiply with 80 mg per liter. You will get 4000 into 10 to the power of 6 mg per day, which comes to 4 tons per day. That is how many tons per month? 120 tons per month. What is the cost of alum? 15 rupees per kg. 1 ton is 1000 kg. So 1 ton is 15,000 rupees. So how many per month? How much? 18 lakhs per month. Every month we are dumping 18 lakhs into water to treat it. But if we use Nirmali seeds, or if we use a combination of 10 mg per liter of lime and 5 mg per liter of Nirmali seeds, maybe the concentration may come down to 20 mg per liter. And instead of 80 mg per liter, if it comes to 40 mg per liter also, you are saving 9 lakh rupees every month as an engineer. And all municipal engineers, our water treatment plants they're all run by persons like you only. So you should always think that, and every day the turbidity of water changes. The quality of water changes every week almost in the river. So you have to adjust what is the best, what is the optimum dosages of these chemicals. If you can do it, then we'll go in a very, very long way. I will cover this in the next topic, but you can just have a glance that is how chlorine is being added to water for treatment. And chlorine is a highly poisonous gas. It is 2.5 times heavier than air. So whenever chlorine gas is leaking, maximum number of people are killed in the world because of chlorine gas. Whenever chlorine gas is leaking, you should never sit, or you should never bow down. You should always stand straight to the extent possible, because chlorine is heavy. You will find it always very close to the floor. Next please. You can find the monthly requirement of chlorine also on similar lines with alum. Next please. Back. We'll stop it here, and last 3 minutes I will, as usual, end the class with the summary of the class. The most important learnings of the day we will recollect, and I invite any 3 or 4 students from you. Today I will give it the